We are diving into our vocab. We're going to go through it pretty quickly because the definitions are already on here. The only part you need to fill in is the term, which I already gave you the answers to, and today we're going to do the notation. Okay? Let's do it. Point. A point is a location in space. It doesn't have size, it doesn't have shape, it doesn't even have a dimension. It's simply a location, like a coordinate. That's a point. So we name points with capital letters. So where it says notation, this is the notation. Or you could just put a capital letter P. You don't even have to write the word point, because when you use a capital letter in geometry, I know that you mean point. Okay? So that's the notation for point. Let's keep going. A line. A line, your textbook's definition is a connected straight path. I think that's kind of an odd definition, but that's okay. It doesn't have thickness. It goes on forever in both directions. Now, what does that word imply, both? What do you think of when you hear both? Two. Very good. So both implies that it goes on in two directions. Some people say it goes on in opposite directions. So that's what that means. Now, this is where it gets a little confusing. You can name a line two ways. You can pick 2 points on the line, and you could name it line AB, capital A, capital B with a line on top. Or sometimes the textbook or other places like to name it with a lowercase italicized letter. See this little letter L right there? So you could call it line L. But when you do that, you have to write the word line in front of it. With the AB, you don't need to write the word line because you already have that line on top. This will make more sense as we start to practice, okay? Promise. So there's 2 ways. There's 2 ways to name it. Plane. A flat surface. It has no thickness, and it extends forever in all directions. So it didn't say both directions, because that would be a line, but extends forever in all directions. So that's our plane. You name a plane with 3 capital letters. 3 capital letters. So you could name it plane XYZ, because you have to use those letters from points that are in the plane. Or, of course, just like a line, you could name it with 1 capital italicized letter, and that'll be in the corner of the plane. Not that planes have corners, but that'll be in the plane, and it'll be capital and italicized. Yes, this is the notation column. Yes. So pretend that this is nice and italicized here, okay? Italicized capital letter. Okay. The next word is segment. A segment is like a line, but you just chopped the arrows off. So a segment is literally like a pen or a pencil. That is a segment. It has a beginning, it has an end. And those are called end points. So how do you name a segment? Well, you name it based off of its end points. You can't just pick any points. You have to name it by its end points. So this is segment CD, because there's a segment over the capital C and the capital D. That's notation. There's no arrows, and that's how I know it's a segment. What's the notation for point P? Oh, just a capital letter P. Capital letter P. All right, a ray. It is part of a line, so instead of taking a line and chopping off the ends, you just chop off one of the ends. So a ray is a part of a line with 1 end point and all the points on one side of the end point. So F, this is called the end point, and then it continues on forever in one direction. That's a band. One direction. So capital F, capital G with a ray on top. That's the notation. This is the notation. Kind of like positive numbers on the number line. Very good. That is representative of a ray. Or like a flashlight. The end point of a flashlight would be the actual flashlight, and then the light coming out of it would be the ray extending on forever. Okay, the next word is collinear points. And I bet I heard people in my class saying this wrong yesterday. So it's pronounced collinear. Say it out loud at your school. Collinear. So, if I said, oh, my coworker is going out of town this weekend, what do I mean? What's a coworker? Oh, I did skip opposite rays. Thank you for telling me. I did skip number 6. This is number 7. We're going to go over number 6 on Friday. There's no notation for it. There is no notation. Leave it blank. So a coworker is like someone who works in the same building as you, someone who works at the same company. So co kind of means same. So when I say collinear, I mean same line. Collinear, same line. Collinear, same line. There's no notation for this. I wrote something in the box, but that's not really the notation. That's just a description. So if you want to leave the notation blank, you can. If you want to write that, you can. Okay? The next word is the opposite of collinear. So what would be the opposite of being on the same line? Not being on the same line. So non-collinear is when they do not lie on the same line. I don't have a slide for that because there's no notation for it. So I want you to flip over to the back. Everybody flip. Flip. And now we're on number 9. There's no notation for 7, 8, 9, or 10. There's no notation, but you can write what I wrote there if you want. And this isn't even the same picture, so just be careful about that. Okay, coplanar means the same thing. Co means same, but planar, too bad that's not an E, means plane. So coplanar are points or lines in the same plane. So collinear, same line. Coplanar, same plane. There's no notation. Non-coplanar, obviously, points or lines that are not in the same plane. So we're skipping that. All right, let's look at this. You're welcome to write this down in your notes, or you're welcome to just watch and answer it out loud. You do not have to take notes every time I show something up here. If it's something you really need to look at again, I'll tell you that you need to write it down. So this is not something you would have to write down unless you really want to. All right, so look at this picture. Name line M in another way. So we're just practicing naming lines here. Good. So you don't have math type in your chat, right? But if you were to name it on a worksheet, you could name it line BA, or you could name it line AB. Do I need to put the word line in front of it? No, because the line is over the AB, and that's how you're communicating to me that it really is a line. You have to put the arrows, though. Number 2, name the point that lies both on line N and line K. How do you name a point? I'm ignoring the people who are answering all of them. You name a point by one capital letter. Yes, it has to be capital, and I'm going to be picky about that, okay? Because one of our objectives that the state tells us is that we have to use precise mathematical vocabulary. So we're going to be precise. Capital E. Name the line that contains point A and point E. Wait a minute. Name the line that contains point A and point E. There is no line up there that contains point A and point E. Just because a line isn't drawn, does that mean it doesn't exist? Ooh, now we're getting into the good stuff. Just because it's not drawn, does that mean that it doesn't exist? No, it does. So, there is a line that goes through A and goes through E. And you know what its name is? Its name is AE, or EA. So, just because a line isn't drawn doesn't mean it doesn't exist. So, I was asked if the order matters when you're naming a line. When you're naming a line, the order doesn't matter. When you're naming a segment, the order doesn't matter. Can anyone guess when the order would matter? Yay! Ding, 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 Anthony. Array. In array, the order matters because array has a direction. It's kind of like a vector, which we're not going to go there in this class. But the order does matter in array. Very good. Parallel lines. Lines in the same plane that do not intersect. What's the fancy word for lines in the same plane? Coplanar. Good. So they're coplanar lines that do not intersect. When I want to show that two lines are parallel in a diagram, I add arrows to them. See those arrows on those lines? That means that they actually are parallel. And then this is the symbol we use. So if I wanted to say line AB is parallel to line CD, I write it like that, and I don't have to write any words at all. Mathematicians are lazy. We like to use symbols instead of words, so that's pretty awesome. AB is parallel to CD. I just said that whole sentence, and all I did was write what's in blue right there. Okay? All right. Take a look at that figure. It's on your notes, but take a look at it. What observations can you make about this figure? I'm going to zoom in a little bit. What is happening in this figure? Good point. Someone said skew lines, which we haven't even gone over yet, and someone said intersecting lines. Interesting. Why is there a dotted line in that picture? Why is there a dotted line? Are they coplanar though? So that dotted line represents when the line pierces through the plane. When the line pierces through the plane, it goes behind the plane and you can't see it anymore. So the dotted line is when I can't see it anymore. It's piercing through the plane and then it comes back out from under the plane down here. So line B is intersecting plane R at point C. These are things you need to practice saying out loud. Line B is intersecting plane R at point C. Is line A in plane R? Is line A in plane R? Yes. Is line B in plane R? No. It's intersecting plane R, but it's not in plane R. Okay? And we're just getting used to this. So if these things are not coming to you right away, that's okay. That we're just learning it. So here's some observations that you could have made. Line A and B will never meet. One is going this way in the front and one is going this way in the back, and they will never meet. So they are what we call skew lines. Skew lines. So like one is here and one is here. This ruler will never meet up with this ruler because they are going separate ways and they are in separate planes. This one will never ever see this one. It's called non-coplanar. So that's our next one, skew lines. The only difference in the definition versus parallel and skew, the only difference is the word not. Parallel lines are coplanar lines that don't intersect. Skew lines are non-coplanar lines that do not intersect. So that's the only difference. So this is parallel, skew. parallel, skew. Okay? All right. Now, just on a notebook sheet of paper or on a white computer sheet of paper, just sketch a grid. You don't have to draw all the lines. In fact, I don't want you to draw all the lines, so I'm going to erase that because I don't want you to think that yours needs to look like that. Just eyeball it and plot point A. So -5, 4. You know what? I'm not even going to put tick marks on there. So I'm going to plot point A. Make sure you name it. Because for what we're doing today, you don't need an actual grid. You don't even need to use a straight edge. You could use the corner of your binder, or sorry, the edge of your binder or whatever. But draw a line through point A and call it M. That's an italicized M. Don't make your line look like my line. So if you have other people at your school, compare your line with the line that they drew. Compare your line M to their line M. So you should probably notice that everyone drew a slightly different line. You all drew line M, you all went through point A, but all of your lines probably looked different. So let's make a conjecture, which is really what geometry is all about. It's about observing things and then making hypotheses, which is kind of like a conjecture. There exists blank line or lines through a single point. Ooh, what's the answer to that? Who's going to get it first? Oh, you got it first. Infinite. Not infinity, but infinite. There exists an infinite number of lines through a single point. Infinite. Infinitely many. Okay? So through any one point, you could sit there for the rest of your life and draw new lines through that single point. All right, I'm going to erase this again because I don't want you to draw a grid or take that time. Now let's plot. Draw a different coordinate plane and plot point B. 3, 5-ish. Reflect B over the y-axis. Whoa! Reflect it over the y-axis. Do y'all know how to do that? You know how to do that. And call it B prime. So we're reflecting it over the y-axis and calling it B prime. That's what B prime means. It's B with a little tick mark. Okay. Draw a line through B and B prime. Draw a line through B and B prime. Dun, 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 dun. Compare your line with the students around you. What do you notice this time? Yeah, hopefully you're discovering that you all drew the exact same line. Now, last period, someone said, well, mine's shorter than theirs. Theirs is longer. Well, do lines have length? No. They go on forever. So no line is shorter than the other. You actually all drew the exact same line. You could even write the equation of that line, but we're not going there right now. Okay? So make a conjecture. There exist blank lines through any 2 points. One unique line. Good. There exists one and only one unique line through any 2 points. So isn't that crazy? When I have 1 point, I can draw an infinite number of lines. But as soon as I have 2 points, I can only draw 1 line. It goes from infinite to 1, just like that. Crazy. Okay, trying to think of what I want to do here. Instead of plotting, I just want you to draw 2 lines on your paper and make sure they intersect. Just draw 2 lines on your paper and make sure they intersect. What do you get when 2 lines intersect? You were trying to be first, and so that's why. Good. When two lines intersect, right there at their intersection, you get a point. So that's what a point is. It's a location in space. It's created by two lines intersecting. Okay? So that's what you get when two lines intersect. You get a point. Now, do all lines intersect? So on your paper, draw two lines that do not intersect. Draw two lines that don't intersect. What do you know about these two lines? So, if lines don't intersect, they have two choices in life. If they're not going to intersect, they can be parallel, but they have one more choice in life. What else could they be if they're not going to intersect? Good. They can be skew. Now, skew lines require 3D. They require 3 dimensions. So you can't really draw skew lines on your paper very well because your paper's 2D. You're limited by that plane. But skew lines you need 3D to see, but they do not intersect. Okay. Can two lines intersect more than once? Now on your paper, draw two lines and make sure they intersect more than once. Draw two lines and make sure they intersect more than once. Miss Stanton loves giving you impossible tasks. You can't do it, right? Like, you could just try your heart out. You could sit here for forever and be like, okay, I drew a line. Okay, now I'm going to draw another one. Okay, he's going to hit him there, and then, oh, he's never going to see him again. You can't go back around. Lines are not allowed to bend. That's in the definition of a line. It has to be straight. So, that is an impossible task. They cannot intersect more than once. So here's our next conjecture, our next hypothesis. If two lines intersect, then they intersect in exactly one point. And tomorrow, I will summarize everything we learned today, and I will let you write it down in your notes. So don't be worried if you're like, I can't catch up, I'm not writing everything she's saying. We will summarize it tomorrow. If two lines intersect, they intersect in exactly 1 point. That says if they intersect, because remember, they don't have to intersect. Okay. Plot 2 points on your paper that are non-collinear. Plot 2 points on your paper, on your graph, that are not collinear. Hopefully you realized, we had a sidebar, hopefully you realized that you cannot draw points you can't draw 2 points and make them non-collinear. You just can't do it. If there was a point on the moon and a point on Jupiter, you could put a line through it. Collinear means I could put a line through it. So it's impossible to draw 2 points that are non-collinear. So let's look at these statements. Any 2 points are collinear. True or false? It is true because I can't think of a single time in the world where I could draw 2 points and no one could connect them with a line. Any 3 points are collinear. False. And it says if it's false, draw a counterexample. That just means prove it wrong. We love proving people wrong. Don't you love proving your parents wrong? Isn't that fun? We get to prove statements wrong in this class. So let's prove that wrong. Boom, boom, boom. I cannot draw one line and connect all 3 of those points. I can't. Okay. This is the exit ticket, which means we are done. All right, let's just sum up what we learned today, and you can start on your homework. This is what we learned today. Through one point there exists, I know you're saying it, I know you know it, an infinite number of lines, and then through any blank points there's exactly one line. 2. Beautiful. All right, we are done.